This presentation concentrates on the concept of functional safety, which is critical for ensuring workplace safety in machines. Functional safety guarantees worker safety by keeping potential hazards in machines under control. The presentation deals with how performance levels are determined, the factors that risk assessments are based on, and the advantages of various safety measures. Additionally, concrete examples are provided to make this information more tangible. At the end of the presentation, recommendations for the safe use of machines are shared. The topics covered include functional safety, performance levels, and risk analysis. Additionally, example applications, such as MTTFD calculations and determining the performance level for a CNC lathe, are provided. Finally, after evaluating the advantages and limitations of safety measures, the presentation concludes with results and recommendations. According to the standard EN ISO 13849-1, 2015, functional safety refers to the safe management of machine functions that could lead to increased risk in case of failure. Safety functions are designed to keep hazardous situations under control and ensure worker safety. These functions are carried out through various systems, such as emergency stop buttons, safety doors, and sensors. Safety control devices detect failures and bring the system to a safe state, ensuring high reliability. The EN ISO 13849-1 standard provides the necessary guidance for the design and evaluation of the safety-related parts of control systems. This standard offers critical steps and criteria to machine manufacturers for creating a safe working environment. Each safety function must be individually defined according to the EN ISO 13849-1 standard, and the required performance level for these functions must be determined. Performance level, PL, is a measure of how effective a safety function is. Levels, ranging from A to E, indicate how well a machine is protected against safety risks. The required performance level, PLR, specifies the minimum requirement for a function in terms of safety, and it is determined through a risk analysis. During the risk analysis, factors such as the severity of the task, the level of hazard, and the function's operating time are considered. This process is seen as a critical step in ensuring machine safety and preventing workplace accidents. Under the EN 954-1 standard, there were three key questions during risk assessment in machine safety: the severity of the injury, the frequency of presence in the hazardous area, and the possibility of avoiding the hazard. Based on the answers to these questions, machines were categorized into specific risk categories, and safety was ensured accordingly. However, the EN ISO 13849-1 standard replaced these categories with performance levels. This new approach aims to measure the performance of safety systems in machines more effectively. Under the EN 954-1 standard, safety categories were determined according to the level of risk in machines. Category 1 involved low risk and simple safety measures, while Category 4 covered the most advanced safety measures for very high-risk applications. The new standard, EN ISO 13849-1, evaluates safety based on performance levels. These levels take into account critical factors, such as fault detection and system failure time. The mean time to dangerous failure, MTTFD, defines the likelihood of a safety function experiencing a dangerous failure. This value assesses the probability of SRP-CS components failing and putting the machine in a hazardous state. Compared to MTTF, only dangerous failures are considered. The ISO 13849-1, 2006 standard simplifies the design process by classifying MTTFD values into three ranges: low, medium, and high. This evaluation plays a critical role in ensuring machine safety. To determine the performance level for a CNC lathe door safety function, factors such as task repetition frequency and the possibility of avoiding the hazard are taken into account. In this example, the operator manually places the workpiece every 10 minutes and remains in the hazardous area for an extended period. The frequency factor is selected as F2, and the possibility of avoiding the hazard is selected as P1, indicating that the hazard can be avoided under certain conditions. As a result, the required performance level, PLR, for this safety function is determined as D based on the risk analysis. This table outlines the advantages, limitations, and application areas of different safety measures. While fixed enclosures are easy to install and cost-effective, they restrict access to certain areas. Movable and adjustable enclosures offer flexibility for different applications, but may provide lower safety levels. Monitored enclosures control dangerous functions, but require additional equipment. Mechanical and magnetic switches offer more complex and reliable safety systems, but may require regular maintenance and additional protective measures. The key concepts related to the machinery directive and safety functions have been outlined in this presentation. We saw how critical functional safety is in machines and how performance levels are determined. Additionally, we evaluated the advantages and limitations of various safety measures. In conclusion, conducting thorough risk analyses, selecting appropriate safety functions, and regularly testing these functions are crucial for ensuring machinery safety. Moreover, steps should be taken to train operators and raise safety awareness. Thank you for listening. Please contact us for your questions.